All right, good day everyone. Today we're going to do 2.6 function operations. Functions can be combined through the four basic operations: addition, subtraction, multiplication, and division. When functions are combined, the result is another function. When adding, subtracting, multiplying functions, the domain is the result of the intersection of the domains of the functions being combined. When dividing functions, the domain is the result of the intersection of the domains of the functions being combined, except for any values that make the denominator equal to 0. Okay. Let f of x equal x cubed, and let g of x equal x squared. Find f of x plus g of x. So if I add these two together, x cubed plus x squared, now those are not like terms, so we cannot combine them. So that is it. And then their domain, well, this is a cubic function, and we know all cubics' domain is negative infinity to positive infinity. Okay, I'll switch colors for my next one. Okay. Then we're going to find f of x minus g of x. F of x minus g of x is x cubed minus x squared. Again, they're not like terms. And again, it's cubic, which means my domain is negative infinity to positive infinity. Okay. Green. Now we have f of x times g of x. Well, f of x times g of x is equal to x cubed times x squared. Okay. Well, when you multiply numbers or expressions with the same base, you add the exponents. So you would get f of x times g of x equals x to the fifth. And the domain, well, to the fifth power, that's negative infinity to positive infinity. No restrictions there. We don't have a square root or a denominator. The last one I need to do is division. F of x divided by g of x. My pen is not being great. Okay, f of x is x cubed over x squared. This reduces to just x. When you divide the same base, you subtract the powers. So f of x over g of x equals x. Now your domain, before you simplified, okay, your domain can't be 0. So my domain here is negative infinity to 0, union 0 to infinity. Okay. Even if the denominator goes away when you simplify. All right, let's practice. Let f of x equal 4x cubed and g of x equal 8x squared. Find h of x equals f of x times g of x. Well, h of x then is going to be 4x cubed times 8x squared. Therefore, 4 times 8, you multiply the coefficients, is 32. And then we add the exponents, x to the fifth. The domain, well, x to the fifth, these powers, they all have a domain of all reals, negative infinity to positive infinity. There's no square root or denominator. Evaluate h of negative 1 if possible. Well, h of negative 1, 32 times negative 1 to the fifth. Negative 1 to the fifth power is just negative 1. So 32 times negative 1 is negative 32. So h of negative 1 equals negative 32. Okay, find k of x, which is equal to g of x divided by f of x. So k of x equals 8x squared over 4x cubed. When you divide, you get 2, and then 2 minus 3 is negative 1, so you have an x on your denominator. So I'm going to say k of x equals 2 over x. The domain of k of x, well, my denominator can't be 0. X cannot be 0. So my domain is negative infinity to 0, union 0 to infinity. Okay, evaluate k of 5 and k of 0 if possible. Well, k of 5 is going to be 2 over x, so 2 over 5. K of 0, though, would be 2 over 0. Not possible. It's undefined. Okay, let's go to our next one. Let f of x equal x squared minus 4x plus 3 and g of x equal 2x cubed plus 3. Find h of x, which equals g of x minus f of x and its domain. So I have 2x cubed plus 3 minus f of x, x squared minus 4x plus 3. So I get 2x cubed plus 3 minus x squared plus 4x minus 3. Don't forget about distributing your negative. Therefore, h of x equals 2x cubed minus x squared plus 4x, and negative 3 and 3 cancel, so that's your h of x. The domain, both of these are polynomials. They have a domain of negative infinity to positive infinity, cubic and quadratic, and there's no square root or denominator, so my domain is negative infinity to positive infinity. Evaluate h of negative 2 if possible. Well, it's in my domain, so it should be possible. So I'd have 2 times negative 2 cubed minus negative 2 squared plus 4 times negative 2. Negative 2 cubed is negative 8. So 2 times negative 8 minus negative 2 squared is 4. 4 times negative 2 is negative 8. Well, negative 2 times negative 8 is negative 16. Minus 4 minus 8. Okay. Negative 16 minus 4 is negative 20. Minus 8 is negative 28. So h of negative 2 is equal to negative 28. Okay, find h of x equals f of x times g of x and its domain. So x squared minus 4x plus 3 times 2x cubed plus 3. So now we're going to distribute. X squared times 2x cubed, 2x to the 5th. X squared times 3 plus 3x squared. Negative 4x times 2x cubed is negative 8x to the 4th. Negative 4x times 3, negative 12x. 3 times 2x cubed is plus 6x cubed. 3 times 3 is plus 9. Okay, now I just have to write it in order. So h of x equals 2x to the 5th minus 8x to the 4th plus 6x cubed plus 3x squared minus 12x plus 9. Domain, there's no restrictions, negative infinity to positive infinity. Okay. Evaluate f of negative 1 and g of 2 if possible. So f of negative 1, it's going to be negative 1 squared minus 4 times negative 1 plus 3. Negative 1 squared is 1. Negative 4 times negative 1 is plus 4 plus 3. F of negative 1, 1 plus 4 is 5, plus 3 is 8. g of 2 is next. I would have 2 times 2 cubed plus 3. 2 cubed is 8. 2 times 8 is 16, plus 3 is 19. Okay, last portion for 2.6. The graphs of f of x and g of x are shown below. Use the graphs to answer the following questions. Let h of x equal f of x times g of x. Evaluate h of 0 and h of 2. So h of 0 is equivalent to f of 0 times g of 0. Well, f of 0, when x is 0, y is 5, times g of 0 is 10. So h of 0 equals 50. Okay, next we have h of 2. F of 2 times g of 2. F of 2 is negative 3. G of 2 is 2. So h of 2 equals negative 6. Find the average rate of change of h on the interval 0 is less than or equal to x is less than or equal to 2. Okay, well, I have both my x's and y's for those values. So I would have 50 minus negative 6 over, if I use 50 first, I'd do 0 first, 0 minus 2. That would be 56 over negative 2. 56 over negative 2 is going to give me negative 28. Find the domain of k of x, which is g of x over f of x. Okay. To get the domain, I need my functions. G of x is first, that's my cubic. And it's a cubic with a over 1, down 1. Well, let's just stretch a 1. So I'm going to have x, and it moved right 2. So x minus 2 cubed plus 2 divided by. Now my quadratic also goes over 1 up 1. So that's going to be x squared. Okay, now I went right 3, so x minus 3 squared minus 4. So if this is k of x, my denominator can't be equal to 0. So x minus 3 squared minus 4 can't equal 0. So if x minus 3 squared can't equal 4, so I'm solving for what x can't be. I get x minus 3 can't equal 2, and x minus 3 can't equal negative 2. Add 3. I would get x can't be 5, and x can't be equal to 1. So my domain would be negative infinity to 1, union 1 to 5, union 5 to infinity, because my denominator can't be 0. Now another place you could have gotten that without solving is if you look at the graph, you have zeros of 1 and 5. That's when your function equals 0. Okay. We are all done with 2.6. Stay tuned for 2.7.